electrolysis of lead to bromide, and in this case there are two objectives that we need to meet. One is to state the products of electrolysis of a binary electrolyte. Number two is to explain the process of electrolysis and define the terms anode and cathode. Now, earlier you have already looked at electrolytes, and in an electrolyte, when you pass an electric current through an electrolyte, the electric current causes decomposition of that electrolyte. Now this time we are looking at specifically molten lead to bromide. Now lead to bromide has two ions, lead ions and bromide ions. And an electrolyte that has two ions, one type of cation and one type of an anion, is referred to as a binary electrolyte. So in this case, lead to bromide is a binary electrolyte. Now, when lead to bromide is molten and the direct current is passed through, there are several observations you're going to make. Number one is that you have a brown gas forming at one of the electrodes, and you're also going to have a silvery metallic ball or lead metal being formed at the other electrode. So in this process, lead to bromide is being decomposed by the electric current into its lead metal and also bromine metal. This process is basically electrolysis. So electrolysis is a decomposition reaction that occurs when a direct current is passed through a molten compound or ionic solution, and in the process that solution is kind of decomposed by that electric current. Now, for us to know what happens where, then we need to understand the system. So in this case, we are having a battery here, and on this battery we have this longer line, and that part or that section from our physics, we know that that one is the positive electrode. So in that case, we have it as a positive electrode. And on the other hand, we have the shorter line, and that shorter line is usually a negative electrode. So in that case, we'll have it as a negative electrode. So, or the negative terminal. Let's not talk about electrode, but it's a negative terminal. This is a positive terminal. Now the positive terminal is attached to an electrode. Now this electrode, we are going to refer to it as an anode. So we're going to call that an anode. So anode is the positive electrode. So it's a positive electrode. And of course, on the other side, we have this terminal, or the terminal, the negative terminal. It is connected to an electrode here, and this electrode, we are going to refer to it as the cathode. Now, in this case then, we note that at the anode, that is where the brown gas is going to be formed. So for us to know the products for now, we need to figure out or to think about the anion. So the anion being the negatively charged ion moves to the positive electrode. So in this case, we can link A and A. So anions move to the anode. And of course, now at this point, when the anions move to the anode, The anode is electron deficient, so it can be able to pick up the electrons from the bromide ion, and in that case it forms a bromine atom. But because bromine cannot exist as an atom, then there is need for two bromide ions to be to actually give up their electrons, and at the end of the day you have the formation of bromine gas. So you have bromine gas being formed, and of course two electrons are released at that point. So we have two electrons being released. Now these electrons will move to so these two electrons will now flow, because there is a cell here which would actually drive the electrons. So they move to the cathode, and our cathode becomes electron rich, and at the cathode cations would actually be formed at that point. So the cations not formed, but they move to the cathode, because the cathode is negatively charged and of course the cation is positively charged. So a cation moves to the cathode, and an anion here moves to the anode. So at this point where you're having the cations, the lead ions of course now can be able to pick up the two electrons. So this is positively charged, they have a charge of 2 positive, and then they can be able to pick up 2 electrons, and at the end of the day you may end up forming, or you're actually going to form lead metal. So Pb or lead metal, and of course this metal is in liquid state. And you also need to note that the melt is also in liquid state. The same case applies to bromine here. The molten lead to bromide with the state symbol is liquid, and of course here this becomes a gas, and it moves out or as a brown gas. Now this process needs to take place either outside, and mostly the better part is to be in a fume chamber, because bromine gas is a poisonous gas. Now there is usually a problem. Some students talk about this being aqueous. Aqueous means something very different. It means that the solution or that substance is actually a solution. So in this case it is not exactly a solution, it is something that is in a liquid state. So it has been molten, so it is not made into a solution. Now at this point then you have two products, bromine gas and lead metal being in that solution. Now what is happening in this case? You are having the lead bromide basically being heated. The solid lead bromide of course has ions that are in fixed positions. So the moment the lead bromide is heated, then you have the lead ions being freed from the crystal lattice, and the bromide ions being freed from the crystal lattice also. The ions move to the respective electrode. So the anions move to the anode, the cations move to the anode, to the cathode, and of course at the anode you have the loss of electrons. Those electrons are supplied to the cathode, where the lead ions in the cathode gain electrons. Now the process at the cathode is actually reduction, and the process at the anode is actually oxidation. So in this case, that is the process by which the electrolysis of lead to bromide occurs. Now, during an examination level question, you're going to be required to draw a diagram showing maybe electrolysis of lead iodide and things like that. So what you need to remember is that you have to ensure that you label your diagram. One is that it has to have a cell, either a cell or a battery. Then there should be 2 electrodes, and you need to label them inert electrodes. Then you have molten lead, bromide or lead iodide, depending on what has been asked. And you should also show that heating occurred. If heating is absent,